Ladies, gentlemen, super intelligent sausages and small yellow teddy bears, however you might identify, you're all welcome here. Today we're dealing with another little film put together by Nicholas Verhoeven here. Nicholas is a student with delusions of grandeur who universally gets things really quite badly wrong every time he makes a video. I have watched this one through for once, rather than just responding off the cuff. Just because I had more time this morning. And this is the best video I've ever seen Nicholas put together. However, it still falls a bit short of where it needs to be. So what we'll do is listen to what Nicholas has to say, make as sparing a commentary as possible along the way, and then fill in the blanks that Nicholas is still missing, as are many others, to further bolster the quite correct, it seems, assertion that LDL does not cause atherosclerosis cardiovascular disease. All right, let's hear it. Nicholas Verhoeven, student. Off you go.
I was watching a debate between a doctor who does not believe the cholesterol-containing vessels called low-density lipoproteins, or LDL, cause heart disease, and another doctor that believes that they do when overabundant. It's a long debate, so I don't expect us to go through piece by piece, especially since I've addressed some of it before. However,
that doesn't mean that the way you addressed it before, Nicholas, was correct, indicated, and a full disclosure of all the information is understood by those of us who are competent in the field.
There is an intriguing point made by the doctor who does not believe LDL is a causative risk factor for heart disease.
Yeah, but when you see who that is, you'll all laugh your tits off. He's quite right on this point, but on many other points, he's vastly mistaken, as I've covered in quite some detail previously, Nicholas, if you'd like to have a check through my catalogue of little films concerning that particular individual.
He points out that if LDL is a causative risk factor for heart disease, why do we not see plaque buildup, which LDL contributes to, in veins?
There you go. I mean, that is sufficient to dismiss the false assertion that LDL cholesterol causes atherosclerosis. It doesn't. It can't possibly, because if it did, it would cause it equally on both sides of the vasculature, the arteries and the veins. It doesn't do that. We're done. I don't see why this ridiculous discussion and argument goes any further than that. But oh well, let's go.
We only see it in arteries, yet they're part of the same circulation and are exposed to the same amount of LDL. That's a great question, and I'd like to address it because there's a little error that can really throw us for a loop unless we catch it. So let's listen in first.
So there you go. These are the two doctors that Nicholas is putting forward as worth listening to remotely on any topic. Either one of them, a psychiatrist who's never practiced. The other one is an osteopath who runs a cath lab and makes little ticky-tocky videos with a little filter over his face and says ridiculous shit like the European Consensus Panel on Atherosclerosis absolutely proves without any question whatever that LDL is causal in heart disease. So neither one of these blokes is remotely worth a second of your attention to listen to anything they've got to say. But all right, Nicholas, what have you got to say?
Is more susceptible to atherosclerosis than and LDL supposedly causes atherosclerosis, and that arteries and veins are exposed to the same amount of LDL, that we don't get atherosclerosis in the native venous circulation.
There you go. The only thing I've ever heard Paul Saladino say that was remotely correct. And it is correct, Paul, that one. You cannot lay the blame for causality of heart disease atherosclerosis on LDL when it does not affect veins and arteries equally. Period. We are done. But there's more to this, of course.
This, to me, is perhaps the most interesting conundrum.
Okay, that's the question. And to his credit, it's true. There are studies where they've taken veins and grafted them onto an arterial blood supply and shown that they develop atherosclerosis.
Right. Ergo, LDL cholesterol right there is exonerated. Isn't it? If you can't see that, Nicholas, or anybody else, then you have a serious problem with basic logic. We're done. Why are these guys not done? I don't know.
So why was there no atherosclerosis before? And even though LDL levels were, well, the same, and now there suddenly is. Gotta admit, that's a pretty tough one to crack.
Impossible.
But let's listen in on more of the argument.
There are proteoglycans in the subintimal space in a vein as well. We know that. If you put a vein...
Proteoglycans, for those that don't know, are involved in retaining LDL particles. They do that for a reason, by the way. They do that when they are activated to do so, when they are synthesized at a certain rate to increase their concentration to attract more LDL. In the case of physical injury to the endothelial cells in certain parts of the high pressure side of the system, not all of it evenly. Whoops.
Into the arterial circulation, it can retain LDL. So
yes, veins absolutely can retain LDL if veins are mechanically, physically injured by some process. It doesn't seem to occur. Ergo, we don't get atherosclerosis. And LDL is therefore not the cause of the disease. Good.
There's no reason that a vein couldn't retain that LDL. It has proteoglycans in the subintimal space, just like an artery does. So it can retain, it has the endothelium that looks exactly the same. And
not exactly the same, but very, very similar.
It should be getting atherosclerosis in the native circulation if LDL or ApoB, which most of the mainstream medical system says causes atherosclerosis, is actually the proximate cause of atherosclerosis.
So there's a lot going on there for whatever reason. And I don't know that we don't understand everything in medicine, obviously, but
no, Arlo, you don't understand dick about fuck regarding anything. You're a buffoon. You're a bought and paid for shill of the pharmacology industry. You promote dangerous contraindicated metabolic poisons to people on a daily basis. Those contraindicated poisons taking the form of HMG coenzyme A reductase inhibitors or PSK9 inhibitors. No good. You have less credibility than Paul Salad I don't know. Okay? Anyone that can be mopped up by someone as stupid as Paul Saladino really is lacking, aren't they, Muhammad? And by the way, you once mouthed off at me suggesting that you don't need my permission to speak at a conference. Is that so, son? Right, carry on.
For whatever reason, arteries are able to retain LDLs.
Yeah.
Yeah. Well, there's your LDL argument. Fucked, isn't it, Arlo? What a shame for you.
Agree. If everything is the same between the artery and the vein in terms of structure and LDL is the same in circulation, then it makes logical sense that the vein would also have atherosclerosis.
Indeed, but it doesn't, does it, Nicholas?
Plaque buildup. I'll come back to that because I'd like to define some of the concepts.
Also, don't forget we put a vein on the other side of the circulation, make it an artery by grafting it there, and it develops atherosclerosis. As sure as little green apple trees grow little green apples. So long as physical injury occurs to that newly placed arterial graft, which it will under certain circumstances, which I'm sure we'll discuss in a minute.
Here, in case you aren't familiar with them. I described LDL before, and there are plenty of studies that indicate it is linked to heart disease due to its movement from the bloodstream past the lining of cells called endothelial cells.
How does that occur, Nicholas? how does an LDL particle get through a layer of cells to the tissues underlying those endothelial cells? How does that happen? Why does that happen? Does it happen evenly across the inside surface of all of the arteries? No, it doesn't. Looks like there's another factor that's causing this to occur. I wonder what that could be. I don't, because I know what that factor is. Let's see if you know what that factor is. Spoiler. Oh.
The reason they get attracted to a region below the endothelial cells called the subendothelium is because some proteins found on the lipoprotein vessel called ApoB is attracted to a charged molecule called a proteoglycan.
Right, so the proteoglycans are expressed as a way of communicating to the LDL that these underlying cells are physically damaged. They are injured in some way. Thus, we need a bunch of cholesterol to be delivered there by the LDL in order to affect the repairs because, well, 50% by weight and volume of every single membrane of every single cell in your body is cholesterol. So, of course, we need raw materials to make repairs. That's what it's doing there. But what caused the injury? Well, we'll get to that.
Which is found in high concentrations in the subendothelium.
Yes, of injured tissues, not of uninjured tissues. Interesting. That's why atherosclerotic lesions don't develop as a carpet evenly across the entire inner surface of the high-pressure side of the vasculature in the arteries. It only develops in set and very predictable zones within that endothelial area of tissue. Wonder where those areas are.
Once they bind to one another, the LDL gets retained.
Yes, in order to deliver the cholesterol there where it's needed. Yes, good.
So if there is a lot of LDL in circulation, more is prone to traverse the endothelial layer.
Well, if that were so, it would happen evenly across the entire inner surface of all the arteries, wouldn't it, Nicholas? It doesn't occur that way, does it? No. Whoops.
And then be retained in the subendothelium. That's
in order to repair the injuries that has occurred that causes the endothelial junctions to loosen up and allow that cholesterol to go through there. Precisely because it's injured, and that's a good thing to get those materials there to affect the repairs. The analogy is that the LDL particles are firemen at a forest fire. We don't blame forest fires on fire crews, do we? No. Okay, so let's have a look at what Nicholas has got up on the screen here just briefly. He's got an opinion piece about mechanisms of oxidized LDL-mediated endothelial dysfunction. He's got another opinion piece on an overview of oxidized LDL and its impact on cardiovascular health. He has a third opinion piece there by the crowd I was talking about earlier, the European Consensus Panel, whose opinion is just that, an opinion, and it's disclaimed as such. It's also bought and paid for. Here is their disclaimer statement, by the way, just for those who have never seen it. Good. Okay, so we can ignore that one. And what have we got here? The fourth one there, arterial retention of apolipoprotein B48 and B100 containing lipoproteins and atherogenesis. Okay, so that'll be a look at histology to see what's in there in these lesions. Okay, so what? That doesn't tell us anything about cause and effect. 5. The central role of arterial retention of cholesterol-rich apolipoprotein B containing lipoproteins in the pathogenesis of atherosclerosis. The triumph of simplicity. So another opinion piece. Not a single piece of experimental work of any kind cited there whatsoever by Nicholas at all concerning the etiology, the causal underpinnings of atherosclerosis. Not one. Good.
It's the argument by conventional understanding as explained in all of these studies. And rest assured, there are...
none of those are studies, Nicholas. They're all opinion pieces, every one of them. That's not a study.
about 50 more indicating the same thing.
No, there are no experimental studies extant anywhere in the literature, Nicholas, that can inform us on the etiology of cardiovascular disease one way or the other. Sorry about that. Just the facts.
Many methods of probing that question. So then,
but none of them are experimental pieces of work. The only way that is actually capable of probing the question of the underpinning cause of the disease process. None of them. Sorry about that.
If all that is true, why is there an exception for veins?
Well, I'll answer that question at the end if Nicholas doesn't get it right, which I know he's not going to.
Well, I did say that.
So stick around to the end for the answer.
I agree with the argument as constructed, but I also mentioned there's a little error that totally transforms the argument.
A little error. Let's hear about your little errors, Nicholas.
The argument is that veins have endothelial cells. Correct. They have the same exposure to LDL. Correct. They have the same proteoglycans. Correct. But there needs to be one more factor discussed that's not being discussed. How much?
Yes. Good. And what causes it to increase? I wonder.
I mean, how much of these proteoglycans exist in the arteries versus veins?
Yes. And why? Because that's the most important thing. Actually, not how much is there is not the most important thing, Nicholas. Why is that so is the most important thing, isn't it?
And if I can add a similar question, what is it made of? You see, these...
Well, what's that got to do with the price of fish in China in 1965?
Proteoglycans are the overall structure, including a protein core and carbohydrate chains called glycosaminoglycans, or CAGs for short. These CAGs come in different forms, and each form retains LDL differently. So if we crack open a study comparing the CAGs between veins and arteries, we see that the artery on the very right has much higher levels of certain CAGs.
And why is that, Nicholas, do you think?
We're looking at 3 different types here compared to the different veins. Additionally, these researchers point out that different CAGs have different affinities or attraction for LDL.
Of course they do.
And which one has the greatest affinity? The one more prevalent in arteries.
Yes, but why is that particular one expressed more prevalently in arteries? And is that expression of that CAG universal and uniform across the entire inner surface of all of the endothelial cells on the high pressure side of the vasculature? No. Why is that, Nicholas?
So this little biochemical difference between the proteoglycans and the amount provides a possible explanation for why arteries build up plaque, yet veins don't.
Of course, though, Nicholas, what it does not do is explain why some areas, predictable areas, clearly predictable areas, develop atherosclerosis and have higher levels of CAGs than do other areas, even on the same side of the vasculature, in the arteries, that is, that do not. Does it, Nicholas? No. Okay? This isn't hard when you actually have some ability to apply logic to a problem.
Or at least not detectably. Except remember that when we graft veins into the arterial circulation, they also develop atherosclerosis. So
goodness, it's almost as if putting them there causes an injury in some way, and that injury in some way causes that what used to be a vein, which is now an artery, to develop more of those CAGs and express more of those CAGs, thus attracting more of the LDLs to become retained there so that they can deliver the cholesterol to that space in order to use that cholesterol as raw material to repair the injury that has caused the CAGs to be expressed in the first place. I wonder what caused the injury. Shall we get to that?
I mean, what's going on there? our body isn't static.
Correct. It responds to injury, among other things, and injuries is what causes the CAGs to build up, and that's what causes atherosclerosis to develop. The cause of atherosclerosis is injury to the endothelial cells of particular predictable zones within the high-pressure side of the vasculature. Good. Nothing whatever to do with cholesterol or LDL or ApoB or any other subfraction of any of the lipoproteins, whatever at all. Nothing. This is a response to injury. Good.
Our cells don't accept their fate once they've been determined to only fulfill one function. Cells can change their gene expression, and there is evidence that changes in blood pressure can drastically alter if cells produce more proteoglycans.
There you go. So on the high pressure side of the vasculature, it is more likely that pressure-induced blood flow dynamics of a certain kind will cause an injury to those endothelial cells. And as such, those cells respond to that injury by producing more proteoglycans, which attract more LDL. Good. Now we know the cause of heart disease. It's a blood pressure, blood flow dynamics related issue. These predictable zones where atherosclerosis develop, where are they? Well, they are where turbulence is present in the blood flow, at bifurcations and at curvatures, where the transit time is elongated in certain parts of the vein, the artery, versus other parts of the artery because of the basic physics of blood flow. The turbulence causes the transit time to be elongated, thus that fluid is exerting that pressure against that particular part of those endothelial cells for longer. That is what's causing the injury, the inflammation, loosening up the gap junctions, causing the production of the proteoglycans and attracting the LDL, which is still not the cause. It's one of the responses to the injury. The cause of the injury, well, the higher your blood pressure, the more likely it is that you're going to have turbulence in your blood flow. All right? What, by the way, is one of the easiest ways to chronically increase your blood pressure? Let me tell you. If you are hyperinsulinemic chronically, that means you will be unable to excrete sufficient sodium, as you normally would. That will raise your blood pressure, and that will basically subject you to the very real probability that you'll develop atherosclerosis. Cause and effect. With logic. First principles. There it is. That's the cause of heart disease. Not lipids of any kind. Good.
Here's a wonderful image of an
Wonderful is not a scientific word, Nicholas. That's not something a scientist would do. A student might, but not a scientist.
artery changing its gene expression and protein production in response to blood pressure changes.
Maybe you should go and have discussions with James de Nobles-Tonio, who's also a non-scientist. He's just a non-scientist with a large list of publications to his name. He proved himself a non-scientist in the last few days, if people want to look at my channel and see how that's gone off.
You can see the yellow tag protein increasing significantly. To be clear, this is not a measure of proteoglycans, just proof that the vasculature is much more flexible than is explained before.
Well, we knew that, those of us who were actually competent physiologists. We've known it for years, Nicholas. I've been teaching this for 20-something years. In my cardiovascular pathophysiology 101 classes, and 201 and 301 and postgraduates. But there you go, that's for another day.
Now, why am I so focused on blood pressure?
Because it's the correct underpinning cause of the blood flow turbulence dynamics which cause the disease, not the LDL still.
Because the arterial side of blood flow has higher blood pressure. So imagine taking an adaptable piece of vein and grafting it to the arterial side. it would likely experience dramatic changes in gene expression and may even dramatically increase its proteoglycan production and maybe even shift the composition of those CAGs on the proteoglycans. So
All of those are correct, Nicholas. All of those will be what's happening, yes.
to say that arteries and veins,
So long as the grafted new artery is subject to a turbulence issue, which is very likely to be because it's been grafted in, isn't it? So there'll be a lip there causing turbulence around that. Yeah? Good. Okay. Physics, though. Just basic physics, first principles, blood flow dynamics. Very straightforward.
are the same structure and therefore would experience LDL the same is simply incorrect. And that doesn't even go into the fact that arteries have more of certain cells, like smooth muscle cells, which also secrete proteoglycans.
Well, they do that, Nicholas, precisely because those smooth muscle cells are there, A, to provide vascular tone, and B, to reinforce those vessels which are under vastly more pressure per square unit space of endothelial surface area. So that's absolutely in line with what we would expect in this case. Yes.
But while I disagree with the argument, once all the facts are presented...
Yeah, but you haven't presented all the facts, Nicholas. You've done very well, and I have to congratulate you. You've done very well on this video, Nicholas. But you didn't quite get there, did you, son? No. You missed the last most important point. Whoops, it's turbulence. That's the problem. So the pathology here is hypertension, not a blood lipid dysfunction at all. Isn't it, Nicholas? Going up any flagpoles for anybody? Hope so.
None of this actually proves that these distinctions are actually the cause for this difference in atherosclerosis, to be clear.
That's right. Correct. They are not. I've just outlined to you what's going on. See if it goes up your flagpole.
However, I still wanted to point out that this mystery isn't so mysterious once you delve a little deeper into the literature. Shockingly, scientists who have dedicated their entire lives to this stuff have thought of a thing or two.
Yes, Nicholas. And when you're one of them, when you finish being a student, that is, and you really actually are an academic in your own right, maybe you might be worth listening to a bit more. I do have to congratulate you on this video, though. You did very, very well for you, because most of your other videos are absolute pustulous nonsense. So congratulations. I'm pleased for you. You did well, but not well enough. The rest of you, you know how it goes. Join me next time when someone will be wrong on interwebs, because it doesn't look like slowing down anytime soon, does it? No. All right. Ciao for now.